Alright, in this video I'll be solving paper 33 for May-June 2024. So make sure to leave a like, subscribe, and let's dive right in. Number 1. Solve the equation 8 to the power 3 minus 6x is equal to 4 times 5 to the power negative 2x. Give your answer correct to 3 decimal places. Alright, so we've been given 8 to the power 3 minus 6x is equal to 4 times 5 to the power negative 2x. So let's start by applying the natural logarithm to both sides. So ln 8 to the power 3 minus 6x is equal to ln 4 times 5 to the negative 2x. Alright, so on the right hand side we are going to apply the law of logarithm that says ln AB is equal to ln A plus ln B. So that means what we have is ln 8 to the power 3 minus 6x is equal to ln 4 plus ln 5 to the power negative 2x. Alright, and then to simplify further, we are going to use the law of logarithms that says ln A to the power n is equal to n ln A. So we're just going to use that to bring down these powers that we have. So this set of powers and this power as well. Okay, so it means this becomes 3 minus 6x ln 8 is equal to ln 4 plus negative 2x ln 5. Alright, and now let's just expand our brackets here. So 3 times ln 8 gives us 3 ln 8. Negative 6x times ln 8 gives us negative 6x ln 8. And this is equal to ln 4 minus 2x ln 5. Now we're going to put everything that is x on one side. So I'm going to move the negative 6 ln 8 to the right hand side, so that we end up with 6x ln 8 minus the 2x ln 5 here, 2x ln 5, and this is equal to our 3 ln 8, 3 ln 8, and then let's move ln 4 to the left, so minus ln 4. On the left hand side, let's factor out x, so this becomes 6 ln 8 minus 2 ln 5, and this is equal to 3 ln 8 minus ln 4. And so if we make x subject of the formula, x is equal to 3 ln 8 minus ln 4 over 6 ln 8 minus 2 ln 5. Now they only wanted to 3 decimal places, so we can just punch what we have into the calculator and get a result. So that's 3 ln 8 minus ln 4, and this is over 6 ln 8 minus 2 ln 5, and this gives us 0.524 correct to 3 decimal places, and that's our final answer. Number 2, find the exact coordinates of the stationary point of the curve y is equal to e to the 2x sine 2x for x is between 0 and half pi. So we're given y is equal to e to the 2x sine 2x. To get the stationary point, we first have to find the first derivative, dy dx. So it means we are differentiating a product. So our dy dx here is equal to, let's start by holding the e to the 2x, then differentiate sine 2x. If you differentiate sine 2x, you get 2 cos 2x plus, now let's hold the sine 2x and differentiate the e to the 2x, so that gives us 2e to the 2x. Alright, so dy dx is equal to, here we can factor out a 2e to the 2x in both terms, so 2e to the 2x, and here on the first term we remain with the cos 2x. From the second term we get our sine 2x. Alright, and this is our dy dx. Since we want to evaluate the coordinates of a stationary point, we can equate dy dx to 0. So 2e to the 2x times cos 2x plus sine 2x is equal to 0. And we can equate each expression to 0. So 2e to the 2x is 0, and then cos 2x plus sine 2x is equal to 0. Alright, so let's start with the equation on the left. If we divide both sides by 2, we get e to the 2x is equal to 0. To get rid of the exponential function, we have to apply the natural logarithm on both sides, and this leads us to having a ln 0. So that would be ln e to the 2x is equal to ln 0. We know that our natural logarithm cannot take values of x that are less than or equal to 0, so this means that x here has no solutions. Alright, and now let's work with our second equation. What we can do here is to divide through by cos 2x, so that's cos 2x over cos 2x. And the reason we're doing this is so that we use the identity that tan 2x should be identical to sine 2x over cos 2x, which we can use over here. And we know that our cos 2x will cancel out in that case, and we end up with a 1 there. So what we have is 1 plus tan 2x is equal to 0. So tan 2x is equal to negative 1. So 2x is equal to arctan of negative 1. So 2x is equal to, let's punch this into our calculator, arctan of negative 1. That gives us negative a quarter pi. If we divide that by 2, it will still be negative and it won't fit within our interval. Alright, we can say that this here is our principal value, and this allows us to use the formula that PV plus pi n should give us our results that fit within the interval. So let's try at n is equal to 1. So at n is equal to 1, we can say PV plus pi times 1. Remember, our principal value is negative a quarter pi. So that's PV plus pi times 1, and that gives us 3/4 pi. Now at first sight, this 3/4 pi looks like it's bigger than our interval here. But remember that our principal value here is representing 2x. So we're actually saying that 2x is equal to 3/4 pi. So our final answer is going to be divided by 2. So x would be 3/4 pi divided by 2, which gives us 3/8 pi. And that does fit within our interval of 0 to half pi. Okay, so now they want both x and y coordinates, so we can substitute into the equation of the curve. Y is e to the 2x sine 2x. Alright, so y is equal to e to the 2 times 3/8 pi sine 2 times 3/8 pi. So y is equal to, here we'll end up with e to the 3/4 pi, e to the 3/4 pi, and then let's evaluate sine of 6/8 pi. That gives us √2/2, √2/2. So y is equal to √2/2 e to the 3/4 pi. Alright, so we can conclude that, therefore, the coordinates of our stationary point are 3/8 pi, and y is √2/2 e to the 3/4 pi. 3/4 pi. So 3/4 pi. And that's our final answer. Number 3. The square roots of 24 minus 7i can be expressed in the Cartesian form x plus iy, where x and y are real and exact. By first forming a quadratic equation in x or y, find the square roots of 24 minus 7i in exact Cartesian form. Alright, so we want to find the two square roots of 24 minus 7i. And we are told that the square roots of this complex number should be in the form x plus iy. Alright, so what we're going to do is we're going to square both sides, and that allows us to get rid of that square root sign. So 24 minus 7i is equal to x plus iy squared, since if you square one side you also have to square the other side. So we've squared this side and we're also squaring that side. So let's expand our right hand side. So 24 minus 7i is equal to, that's x squared plus I squared y squared plus 2xyi. Alright, so 24 minus 7i is equal to, we can use the idea that I squared is equal to -1. So that means we've got x squared minus, because I squared is -1, y squared plus 2xyi. So that means on the right hand side our real part will come from this x minus y squared, and then our imaginary part is going to come from 2xyi. So we can compare both sides to say that on the left hand side our real part is 24. So 24 must match the real part on the right hand side, which is our x squared minus y squared, and then our imaginary part on the left hand side, -7, should match the imaginary part on the right hand side, 2xy. We can omit the i's because they would eventually cancel out. But anyways, what we end up with are two equations in terms of x and y that we can solve simultaneously. So in this case, I'm going to make x the subject of the formula in this equation. So x is equal to -7/2y. And we can substitute that x into this first equation. So 24 is equal to x squared. We said x is -7/2y, and this is squared, minus y squared. Alright, so 24 is equal to, square the numerator, square the denominator. That becomes 49 over, that's 4y squared. Be careful, yeah, square the 2, then square the y, and this is minus y squared. Alright, so let's get rid of our denominator 4y squared by multiplying through by 4y squared. So this becomes 24 times 4y squared is equal to 49 minus, that's being multiplied by 4y squared, so that becomes 4y to the 4. And on the left we've got 24 times 4, which is 96. So what we have is 96y squared is equal to 49 minus 4y to the 4. Let's put all the terms on one side. So we've got 4y to the 4 plus 96y squared minus 49, and this is equal to 0. Alright, so we've got a quadratic in y squared. So let's solve that using the quadratic formula. So y squared is equal to minus b, so minus 96, plus or minus the square root of, that's b squared minus 4ac, and this is all over 2a, so 2 times 4. This means y squared is equal to, let's punch this into the calculator, that's -96 plus the square root of 96 squared minus 4 times 4 times -49, and this is over 2 times 4, and this gives us, we've got y squared is half when we use the negative sign, and that's when we use the positive sign rather, and from the negative sign we get -49/2. Alright, So those are our two solutions. Do we have space? No, we don't. Let's work it out on the side. So we've got y squared is equal to 1 over 2, and we've got y squared is equal to negative 49 over 2. Alright, so let's take the square root on both sides. Remember to put plus or minus. So y is equal to plus or minus root 1 over 2, which is plus or minus root 2 over 2. And then from this equation, we can tell that y squared is giving us a negative number. This means that y is equal to root negative 49 over 2 would actually give us imaginary values for y. And in this case, we know that our x and y should be real values. So we can ignore that solution over there because it gives us no real solutions. So you can just write y equals no real solutions. It gives us imaginary solutions. Alright, so now that we've got y is plus or minus root 2 over 2, we have to evaluate the x values. So we've got x is equal to negative 7 over 2y. Let's start with at y is negative root 2 over 2. So that gives us x is equal to negative 7 over 2 times negative root 2 over 2. So this means that x is equal to, the negative signs here cancel out, those 2 and that 2 cancel out. So we've got 7 over root 2. Okay, so let's evaluate at y is positive root 2 over 2. X here is equal to, that's negative 7 over 2 times y is root 2 over 2. Alright, so our 2's will cancel out here, so x is equal to negative 7 over root 2. So we can conclude that therefore our two square roots of the form x plus iy are, here we've got 7 root 2 from here, and that gives us a y of negative root 2 over 2, and this is in the form x plus iy, right? And let's do the same for the other one. We've got negative 7 over root 2, and this is plus root 2 over 2i. Alright, and those are the two square roots of our complex number. That's a very rare question, that one. Number 4, the variables x and y satisfy the equation ky is equal to e to the cx, where k and c are constants. The graph of ln y against x is a straight line passing through the points 2.80, 0.372, 5.10, 2.21 as shown in the diagram. Find the values of k and c. Give each value correct to two significant figures. So we've been given an equation here with multiple variables. So that's ky is equal to e to the cx. And we are required to reduce this to a linear form so that we can evaluate k and c. So to do that, we have to apply the natural logarithm on both sides. So that's ln ky is equal to ln e to the cx. And so on the left hand side, we can use the law of logarithms that says ln ab is equal to ln a plus ln b. So that gives us ln k plus ln y. And on the right hand side here, we've got inverse functions here, so they'll cancel out and we end up with cx. Now we want a line for ln y against x. So we want to make our ln y here the subject of the formula. So ln y is equal to cx minus ln k. Alright, so now that we're at this stage, we can actually compare this to the equation of a straight line. We know that a straight line is of the form y equals mx plus c. So in this case, our y is going to be ln y. because our line is ln y against x. It's not y against x. So in this case, the y is the same as the ln y. The ln y is representing y. Then our gradient m will be c, and then x is x. And then our y-intercept, c, is being represented by the negative ln k. So we can actually evaluate c by first finding our gradient. We know that to find the gradient of a line, we need 2 points, and in this case, we have been given those 2 points. So let's find the change in y. That will be 2.21 minus 0.372. And then let's also find the change in x. So that's 5.10 minus 2.80. Let's punch this into the calculator. That's 2.21 minus 0.372 over 5.1 minus 2.8. And that gives us 919 over 1150. And we said our gradient m is also equal to c. So it means we can say that our c is equal to 919 over 1150. Now they want c correct to 2 significant figures, but I won't simplify it just yet because we still want to use it to evaluate k. Alright, so now that we have c, we can go ahead and evaluate k by using one set of coordinates. We can use this set, and then we'll also use our gradient m. Alright, so our coordinates are 2.80 and 0.372, and we're saying our c is 919 over 1150. Alright, so we can substitute. We're saying the equation that we have here is ln y is equal to cx minus ln k. So our graph, as we said earlier, is ln y against x. So it means that our coordinates are of the form x ln y, right? So take note of that when you're substituting. So ln y is going to be substituted by 0.372, and this is equal to c. Our c is 919 over 1150, and then our x is 2.80, and this is minus ln k. Alright, so let's simplify and solve for ln k. So 0.372 is equal to 919 over 1150 multiplied by 2.8, and that gives us 6433 over 2875 minus ln k. So ln k would be equal to that 6433 over 2875 minus 0.372, and that gives us 1.865565217. I'm using the full calculator display because I don't want to round off prematurely. Now to evaluate k, we need to get rid of this ln, and to get rid of ln we can use its inverse function, which is the exponential function. So apply the exponential function to both sides. That becomes k is equal to 1 e to the 1.865565217. K is equal to, let's punch that into the calculator, and that gives us, or I can round this off to the accuracy. They want 2 significant figures, so that's 6.5. So we can conclude that therefore c is equal to, we can now give our c correct to 2 significant figures, so that's 919 over 1150, which gives 0.80, and k we said is 6.5 to 2 significant figures, and that's our final answer. I should write k here. Alright, number 5, express 6x squared minus 2x plus 2 over x minus 1 times 2x plus 1 in partial fractions. Okay, so I'm just going to start by expanding our denominator. So that is 2x squared Then we've got x minus 2x, so that's minus x minus 1. Alright, so note how the highest power in the denominator is equal to the highest power in the numerator. This means that what we have is an improper fraction. Now, if you prefer to use long division to evaluate the constant, please do so. But in this case, I am not going to use long division. I will explain the method that I prefer to use. So we're going to start off by copying the denominator exactly as it is to our numerator. So that's 2x squared minus x minus 1. Now for this equal sign to be valid here, it means our numerators have to match. So for us to do that, I'm going to start by looking at the coefficient of our x squared. Our coefficient here is 6. What number can I put outside the bracket that multiplies this 2x squared so that we get 6x squared? I can put a 3 here, because if we were to expand 3 times 2x squared gives us the 6x squared. Alright? But note that putting a 3 outside the bracket gives us problems here, because the term in x would be 3 times negative x, which is negative 3x. But we're saying that on the left hand side we've got a negative 2x. So it means we're going to have to add an x for that to be equal. So we add the x outside the bracket. And for the term independent of x, here we've got 3 times negative 1, which is negative 3. But on the left hand side we've got a 2. So it means we're going to have to add by 5 for those to be equal. So we add by 5 outside of the bracket. Alright, so what this allows us to do is we can split the fraction over here. And we've got 3 times 2x squared minus x minus 1, and this is over 2x squared minus x minus 1 plus x plus 5 over 2x squared minus x minus 1. And for this term we can cancel out and we have our constant, which is 3. So 3 plus x plus 5 over 2x squared minus x minus 1. And now we can carry out the decomposition to partial fractions for this term that we have here, and it is a proper fraction. So that becomes x plus 5, and I will use the original denominator we were given. I need the factors, so that's x minus 1 times 2x plus 1. X minus 1 times 2x plus 1. We've got 2 linear factors, so that's a over x minus 1 plus b over 2x plus 1. Let's get rid of all our denominators. So that's x plus 5 is equal to a times 2x plus 1 plus b times x minus 1. Okay, so let's start by evaluating a. To evaluate a, we have to make this bracket over here 0, and that means we have to make x equal to 1 for that bracket to be 0. So that becomes 1 plus 5 is equal to a times 2 times 1 plus 1. So 6 is equal to, that's 2 plus 1, which is 3a. Divide both sides by 3. A is equal to 2. Alright, now let's evaluate b. So let x equal to, we have to make the bracket that we have over here equal to 0. So that means we have to substitute x with negative 1 over 2. Alright, so that becomes negative 1 over 2 plus 5 is equal to b, open bracket, negative 1 over 2, negative 1. So negative half plus 5 gives us, that's negative half plus 5, that gives us a 9 over 2. And then we've got negative half minus 1, which is negative 3 over 2. So we've got negative 3 over 2b. So let's multiply both sides by negative 2 over 3 to make b subject of the formula. So that means that should be a negative 2 over 3. Negative 2 over 3. So that means here our b would be equal to, that's negative 3. Alright, so we have decomposed that into partial fractions. It means this here can be written as x plus 5 over x minus 1 times 2x plus 1. This is equal to a, which we said is 2 over x minus 1 plus b is negative 3, right? Yes, b is negative 3, so this should be minus 3 over 2x plus 1. But don't forget, we also have our constant here. So our final answer for the decomposition of this original fraction we were given would be that, therefore, our 6x squared minus 2x plus 2 over x minus 1 times 2x plus 1 is equal to our constant 3 plus the decomposition of this fraction here, which is 2 over x minus 1 minus 3 over 2x plus 1, and this here is our final answer. Number 6, part A. On an Argand diagram, shade the region whose points represent complex numbers z, which satisfy both the inequalities the modulus of z minus 4 minus 3i is less than or equal to 2, and the argument of z minus 2 minus I is greater than or equal to 1 over 3 pi. Alright, so I'm just going to factor out a negative sign in that inequality here. So z minus, that would be 4 plus 3i, and this is less than or equal to 2, and then I'm going to do the same for our argument here. So that becomes the argument of z minus, we're factoring out the negative sign, so that's 2 plus I, and this is greater than or equal to 1 over 3 pi. Alright, so let's draw a complex plane. This is our imaginary axis, and this here is our real axis. So real axis, imaginary axis. Alright, so let's start with the first inequality. This is a circle with the center 4, 3i, and it has a radius of 2. Okay, so our point 4, 3i, let's say this is 1, this is 2, this is 3, this is 4, so 4 would be here, and then we want 3i in the imaginary axis, so 3i is there. That means our center should be round about here, and then we want a circle with a radius of 2, so something like that, and that looks good here. And then we want to do the argument now. So this means we want to open an angle of 1 over 3 pi from a horizontal line that goes through the point 2i. So 2i would be, that's 2, and then I would be here. So this point, let's draw a horizontal line that goes through this point. I'm just going to make it dotted. Right, we've got a dotted line like this. And from this line, we want to open an angle of 1 over 3 pi. 1 over 3 pi, that's 60 degrees. So use your protractor to open an angle of 60 degrees. I'm going to assume that it would look like this. This is 1 over 3 pi. Alright, so now that we've drawn the diagrams, we need to figure out the region that they want. So for the circle, they want less than or equal to, so that means they want the region inside of the circle. And for the argument, they want greater than or equal to 1/3 pi, so they're looking for the region that's above this blue line, that's above the 1/3 pi. So combining the two inequalities, we want the region inside of the circle, but that's also above this blue line. So that region is this region that we have over here. And that there is our Argand diagram. Part B, calculate the greatest value of argz for points in this region. The greatest value for argz for points in the shaded region will come from that point over here going to our origin, right? And so the angle that we're looking for is this angle, and I'll call it angle theta, right? We want theta. But we're not going to find theta directly, we're actually going to split it into two smaller angles. So we're going to draw two smaller triangles that will help us evaluate theta. This is a right angle since that's a tangent, and then going back to the origin. Alright, and then we'll also have a green triangle below that, going this way and then that way, and also along our complex number here. Alright, so those are the two triangles, and we're saying theta would be the sum of the green angle plus the red angle above. So I'll call our red angle, I'll call it alpha, and we can call our green angle beta. Alright, so let's start by evaluating our alpha. So I'll just take the triangle that we have outside here so we can see what's going on. Right, this is a right angle triangle. Notice that this line over here, let me just label our angle here, this alpha. Notice that this line is the radius of the circle, so that's 2 units, and then this line is coming from the origin and going to the complex number, so that would be the modulus of our complex number. So the coordinates here are 4, 3i, so that means our modulus would be the square root of 3 squared plus 4 squared, which is 9 plus 16, 25, root 25 is 5. So that's 5 over there. So we can find alpha by saying that we've got the opposite and the hypotenuse. So sine alpha is equal to opposite, which is 2, over 5, which is the hypotenuse. So alpha is arcsine of 2 over 5. Alright? So that's alpha. Now we need to find beta. So let's draw our green triangle on the side. This is our triangle here. This is the angle beta. That's the angle we're looking for. We know that this line here, this hypotenuse, is a length of 5 units. It's the modulus of our complex number. And then we know that the distance from here to here would be 4 units because of this 4 over here. Alright, so we can go ahead and find our beta by saying that we've got the hypotenuse and we've got the adjacent. So cos beta is equal to our adjacent, which is 4, over our hypotenuse, which is 5. So beta is equal to arc cos of 4 over 5. Alright, and remember that in the beginning what we were looking for was theta, and we divided our theta into 2. We say theta would be the sum of these two angles, alpha plus beta. So we can, in fact, let me write it here. Theta is alpha plus beta. Theta would be equal to, what's our alpha? Our alpha is arcsine of 2 over 5 plus beta, which is arc cos of 4 over 5. So we can punch that into the calculator. That's arcsine of 2 over 5 plus arc cos of 4 over 5. And that gives us 1.06 radians. And this here would be the greatest value of argz. Number 7. Let f of x equal 8x cubed plus 54x squared minus 17x minus 21. Part A. Show that x plus 7 is a factor of f of x. Alright, using the factor theorem, we know that it says that if x plus 7 is a factor of f of x, then f of negative 7 must be equal to 0. Right? So that's what we have to prove. We have to prove that f of negative 7 is 0, which would mean that x plus 7 is a factor of f of x. So let's substitute x with negative 7 in f of x. Alright, so f of negative 7 is, that's 8 times negative 7 cubed plus 54 times negative 7 squared minus 17 times negative 7 minus 21. Alright, I'll simplify each term individually. So we've got 8 times negative 7 cubed, which is negative 2744. Then we've got 54 times negative 7 squared, that's positive 2646. And then we've got minus 17 times minus 7, which is positive 119 minus 21. Alright, so putting everything together here, we've got minus 2744 plus we've got 2646 plus 119 minus 21, which gives us 2744. And this shows that f of negative 7 is in fact 0. Therefore, x plus 7 is a factor. Let me write that properly, is a factor of f of x. Alright, and that's our final answer. Part B, find the quotient when f of x is divided by x plus 7. Alright, so x plus 7, and we want to carry out long division. We've got f of x, which is 8x cubed plus 54x squared minus 17x minus 21 minus 17x minus 21. Alright, so we're going to say x into 8x cubed, that gives us 8x squared. Then we've got x times 8x squared, which gives us 8x cubed. Then we've got 7 times 8x squared, which gives us positive 56x squared. Alright, and now we subtract 8x cubed minus 8x cubed gives us a 0. Then 54x squared minus 56x squared, that's minus 2x squared. Bring down the negative 17x. Alright, then we're going to say x into negative 2x squared, that gives us a negative 2x. Then x times negative 2x, that's negative 2x squared. Then 7 times negative 2x, that's negative 14x. And then we subtract, so negative 2x squared plus 2x squared, that gives us a 0. Negative 17x plus 14x gives us negative 3x. Let's bring down our negative 21. Alright, so x into negative 3x gives us negative 3. Negative 3 times x, that's negative 3x. Then negative 3 times 7, that's negative 21. Okay, and so if we simplify, this should cancel out to give 0. So therefore, our quotient is, that's 8x squared minus 2x minus 3, and that's our final answer. Part C, and solve the equation 8 cos cube theta plus 54 cos squared theta minus 17 cos theta minus 21 is equal to 0. Notice how this is pretty much the same as our function f of x, which is 8x cubed plus 54x squared minus 17x minus 21. So our original function f of x is 8x cubed plus 54x squared minus 17x minus 21 is equal to 0. Notice that the only change that they have made is to replace x with cos theta. And so what that allows us to do is that we know that the factors of f of x are x plus 7 times 8x squared minus 2x minus 3. So we know that f of x is equal to x plus 7 multiplied by 8x squared minus 2x minus 3. And we've shown here that the only change that they've made is they've replaced x with cos theta. So it means we can write the equation that we've been given there as cos theta plus 7 multiplied by 8 cos squared theta. You're just replacing x with cos theta, minus 2 cos theta minus 3, and this is equal to 0. And so instead of starting with this difficult polynomial in cos theta, we can just start with the factors for the equation here, and we can start working from here. So let's equate each bracket to 0. So we've got cos theta plus 7 is equal to 0, and we've got 8 cos squared theta minus 2 cos theta minus 3 is equal to 0. So here cos theta is negative 7, which will lead to no solutions because that's outside the range of y equals cos theta. So theta has no solutions. We should be able to factorize this by side. Let me put 4 cos theta here and 2 cos theta. This is equal to 0. 1 factors of negative 3. So we can do, let's do a negative 3 here and a positive 1. So 4 times 1 gives us 4 minus 3 times 2. So that's negative 6 plus 4, which gives us a negative 2. Alright, so that's correct. So let me just scroll down here. We can equate each of our brackets to 0. So let's write that down here. We've got 4 cos theta minus 3 times 2 cos theta plus 1 is 0. So we can say 4 cos theta minus 3 is 0. Or we can say 2 cos theta plus 1 is 0. So in this case, 4 cos theta is 3. So cos theta is 3 over 4. So theta is arc cos of 3 over 4. And so our principal value here would be equal to, what are our units? We are in degrees. Okay. So let me change my calculator to degrees. This is arc cos of 3 over 4, and this gives us 41.40962211, and this does fit within our given interval of 0 to 360. But we should also have a second solution. So to get the other value within the interval, we can use the formula plus or minus PV plus 360 N. So that value will come from N is equal to 1, and it will actually come from negative PV. You can check the positive PV solution. It's going to be outside of our interval. So that's going to be 360 minus our principal value, which is 318.59 and so on, right? These are the two solutions we get from this equation. Now let's check out our other equation. So this becomes 2 cos theta is negative 1. So cos theta is negative 1 over 2. So theta is arc cos of negative 1 over 2. So our principal value here is equal to, let's punch this into the calculator, that's arc cos of negative 1 over 2, and that gives us 120 degrees. Alright, and again we'll use the formula plus or minus PV plus 360 N, and this is at N is equal to 1, and again we should get our solution from negative PV plus 360 times 1. So that's going to be 360 minus 120, or minus 120 plus 360 if you prefer, which gives us 240 degrees. So we can conclude that we've got 4 solutions. Theta is equal to 41.4 degrees. Our principal value is also a solution, and we've got 120 degrees. we've also got 240 degrees, and then finally we've got 318.6 degrees, and that there is our final answer. Number 8, part A. Express 3 cos 2x minus root 3 sine 2x in the form r cos 2x plus alpha, where r is greater than 0 and alpha is between 0 and half pi. Give the exact values of r and alpha. Alright, so we've been given 3 cos 2x minus root 3 sine 2x, and we want to express this in the form r cos 2x plus alpha. So let's just expand our right hand side using the compound angle formula for cos. So that would become r cos 2x cos alpha minus r sine 2x sine alpha. And I'm just going to rewrite this so that we've got our cos alpha coming first, r cos alpha cos 2x minus r sine alpha sine 2x, and we're saying that this is always equal to 3 cos 2x minus root 3 sine 2x. I want to make a comparison here, right? So this cos 2x minus root 3 sine 2x. So on both sides here we already have cos 2x here, so it must mean this 3 here must be equal to the r cos alpha, right? So we can say r cos alpha is equal to 3. And then for the sine 2x, we already have it on both sides, so it must mean the root 3 here is equal to r sine alpha, right? So r sine alpha is equal to root 3. So we can say cos alpha is 3 over root 3, and likewise here we can say sine alpha is equal to root 3 over r. So we can use this information to draw a right-angled triangle, right? And our angle alpha is over here. We know that using SOHCAHTOA, this is opposite over hypotenuse. So the opposite of alpha must be equal to root 3 from there, and then our hypotenuse is r, and then from cos alpha we know that that's adjacent over height. So our 3 here is our adjacent. So this here is 3, this is an r, looks like a 12. Alright, so using this right angle triangle we can evaluate both alpha and r. So I'm going to start by evaluating alpha. So we've got opposite and we've got adjacent. So we can say that tan alpha is equal to our opposite, which is root 3, over our adjacent, which is 3. So alpha is equal to arctan of root 3 over 3. So alpha is equal to, let's punch that into the calculator. What are we in? We're in radians. Alright, so let me change to radians. That's arctan of root 3 over 3, and that gives us 1 over 6 pi. So alpha is 1 over 6 pi. And we can find r using Pythagoras theorem. So r is root 3 squared plus 3 squared. So r is equal to, let's punch that into the calculator, that's the square root of root 3 squared plus 3 squared, which gives us 2 root 3. So we can conclude that therefore 3 cos 2x minus root 3 sine 2x can be written as 2 root 3 cos, they want it in the form 2x plus alpha. So cos 2x plus alpha, which is 1 over 6 pi. 1 over 6, I should put a positive sign. So plus 1 over 6 pi. And this here is our final answer. Part B says, hence find the exact value of the integral from 0 to 1 over 12 pi. for 3 over 3 cos 2x minus root 3 sine 2x squared dx, simplifying your answer. Alright, so I believe this is from part A, that part 3 cos 2x minus root 3 sine 2x, and we say that this is equal to this. Alright, so we can replace that and say that this is the integral from 0 to 1 over 12 pi of 3 over, what do we have, 2 root 3 cos 2x plus 1 over 6 pi, and this is squared. Alright, so to simplify here, we are going to use the identity that we know that sec x can be written as 1 over cos x. So that must mean sec of 2x plus 1 over, I'm missing a bracket here, right? Sec of 2x plus 1 over 6 pi must be equal to 1 over cos 2x plus 1 over 6 pi. So before we use that, actually, let's just distribute this power 2 that we have in the denominator. So that's the integral from 0 to 1 over 12 pi of 3 over, we're going to square the 2 root 3. So 2 root 3 squared gives us a 12. So we've got 12, and then we're going to square the cos. So that's cos squared 2x plus 1 over 6 pi. So you square the 2 root 3, then you square the cos. Alright, and now we can use this identity here that we have. And so it means we've got the integral from 0 to 1 over 12 pi. This here is going to cancel out and give us 1 over 4. So we've got a quarter. And then we said 1 over cos 2x plus 1 over 6 pi can be written as sec. And notice that this is squared, so our sec will also be squared, and that's 2x plus 1 over 6 pi. And there should be a dx here and a dx here. We can take the 1 over 4 outside of the integral sign. Alright, and we can integrate our sec squared 2x plus 1 over 6 pi. And this is with respect to x. So this gives us 1 over 4. Differentiate the 2x over here, you get a 2, so we're going to divide by 2. If you differentiate 1 over 6 pi, that's a constant, you get 0. And then when you integrate sec squared, you get a tan, so this is tan 2x plus 1 over 6 pi. And our limits are from 0 to 1 over 12 pi. So this is a quarter. Let's substitute our limits. We'll start with the upper limit, half tan of 2 times 1 over 12 pi plus 1 over 6 pi minus our lower limit, which is half tan of, that's 2 times x, that will be 2 times 0, and then we've got 1 over 6 pi. So let's simplify. We've got a quarter here, and let's punch 1 over 2 tan, that's 2 times 1 over 12 pi, so 1 over 6 pi plus 1 over 6 pi into the calculator, and we get, that's root 3 over 2 minus, we'll do the same for our lower limit, so that's half tan of 1 over 6 pi. Alright, that's root 3 over 6. And now I'm just going to punch this into the calculator. That's a quarter times root 3 over 2 minus root 3 over 6, and that gives us root 3 over 12. So therefore our final answer is root 3 over 12. Number 9. A container in the shape of a cuboid has a square base of side x and a height of 10 minus x. It is given that x varies with time where t is greater than 0. The container decreases in volume at a rate which is inversely proportional to t. When t is 1 over 10, x is 1 over 2, and the rate of decrease of x is 20 over 37. Part A, show that x and t satisfy the dE dx dt is equal to negative 1 over 2t times 20x minus 3x squared. Alright, a lot is going on over here. Let's break it down step by step. So we've got a cuboid which has got a square base of x times x, and then that cuboid has a height of 10 minus x. So if we wanted the volume of our cuboid, we'd say x times our height of 10 minus x, right? So the volume of our cuboid is x squared times 10 minus x, which we can further simplify to 10x squared minus x cubed. Alright, so that's the first part. And then we're told that the container decreases in volume at a rate, so we're monitoring the rate of change of the volume, so that's dv dt. I'll come back to the decreases part, and this is inversely proportional to t. This is inversely proportional to t, so that's 1 over t over here. And we can write this as dv dt is equal to our constant of proportionality over t. Now here they've told us that the volume is decreasing, right? So that means the rate of change of the volume is going to be negative. And using this information, they want us to create this differential equation. So to do that, we can come up with a chain rule and say that dx dt must be equal to, where do we have an x? Our x is coming from the volume equation, so that must come from dx dv multiplied by, we need a t in the denominator, so that's going to come from our dv dt. And you should check, if you cancel out your dv's, you get dx dt. Alright, so we can go ahead and evaluate dx dv and evaluate dv dt. So we'll start with dx dv. That will come from our volume equation. So we need to differentiate. We've got v is equal to 10x squared minus x cubed. So dv dx is equal to, bring down the 2, so that becomes 20x minus, bring down the 3, subtract 1 from the power, that is x squared. Alright, so this here is dv dx, but notice that in our chain rule here, we want dx dv. So we want the reciprocal of dv dx. So what we're going to do is we're going to flip the fraction on this side, and what you do on one side, you do on the other side. So we'll also flip this fraction. So that means our dx dv can be written as 1 over 20x minus 3x squared. Alright, so that's our dx dv. So we have dv dt, but it's in the form negative k over t. We'll simplify that in a bit. We're going to use our chain rule here to say that what we have right now is dx dv, which is over here. That's 1 over 20x minus 3x squared multiplied by our dv dt, which is negative k over t, negative k over t. So dx dt is equal to, that's negative k over t times 20x minus 3x squared. And hopefully you can see that we are approaching that dE that they want us to show. The only difference is that we've got this k. We need to evaluate what k is, right? And we can use the information that they've given us, which is that t is 1 over 10, x is 1 over 2, and the rate of decrease of x, so rate of change of x, that's dx dt, is equal to, since they say decrease, we know that that's negative, and that's 20 over 37. So we can use that information and substitute it into the equation we have over here and evaluate k. So that's negative 20 over 37, that's our dx dt, and this is equal to negative k, and this is being divided by t. T is 1 over 10, so 1 over 10 multiplied by 20 times x. X is 1 over 2, so 1 over 2 minus 3 times 1 over 2 squared. Alright, so negative 20 over 37 is equal to negative k over. Let's punch what we have on the denominator into the calculator. That's 1 over 10 multiplied by, that's 20 times 1 over 2 minus 3 times 1 over 2 squared, and this gives us 37 over 40. So that's 37 over 40. So multiply both sides by negative 37 over 40. K is equal to negative 20 over 37 multiplied by negative 37 over 40. Alright, this gives us that K is equal to, that's negative 37 over 40 times negative 20 over 37. That gives us K is 1 over 2. K is 1 over 2. So this means that our dx dt is equal to, we're going to replace our K here with 1 over 2. So that's negative 1 over 2, and this is all over t times 20x minus 3x squared. And if we resolve our fraction, dx dt is equal to negative 1 over 2t times 20x minus 3x squared. And that's exactly the differential equation that they have over here, so we have proved that. Part B, solve the differential equation obtaining an expression for t in terms of x. Alright, so we've got dx dt is equal to negative 1 over 2t times 20x minus 3x squared. So let's move everything that is x to the left. That would be 20x minus 3x squared dx, and this is equal to negative 1 dt. This is over 2t. Okay, so we've separated our variables so we can carry out integration on both sides. So let's integrate on the left. We get add 1 to the power, that becomes a 2, divide by the new power, minus 3x, add 1 to the power, divide by the new power, plus a constant of integration is equal to negative 1 over 2 ln t. Okay, so let's simplify our left hand side. That's 20 over 2, which is 10x squared, minus 3 over 3, that cancels out, so x cubed plus c is equal to negative 1 over 2 ln t. And we can use the information they gave us in the question to evaluate our constant of integration. They gave us that t is 1 over 10 when x is 1 over 2. So let's write that down. We've got t is 1 over 10 when x is 1 over 2. Let's substitute and evaluate c. So that's 10 times 1 over 2 squared minus 1 over 2 cubed plus c is equal to negative 1 over 2 ln 1 over 10. Alright, so on the left hand side we've got 10 times 1 over 2 squared minus 1 over 2 cubed, which is 19 over 8, plus c is equal to negative 1 over 2 ln 1 over 10. So this means that c is equal to negative 19 over 8, negative 1 over 2 ln 1 over 10. Alright, so now that we have c, we can substitute it into this equation. So that becomes 10x squared minus x cubed minus 19 over 8 minus 1 over 2 ln 1 over 10, and this is equal to negative half ln t. They want an expression for t in terms of x, so they want us to make t subject of the formula. So to do that, let's multiply both sides by negative 2. So ln t is equal to negative 20x squared positive 2x cubed. Be careful with your signs here. And then we've got negative 2 times negative 19 over 8. So that becomes a positive 19 over 4. And then we're going to get negative half times negative 2, which gives us a positive 1. So that's ln 1 over 10. Okay, and now we can just apply the exponential function to both sides to get rid of the ln here. And so this becomes t is equal to, I'll write it as exp, which is an alternate notation for the exponential function. So that's plus 2x cubed plus 19 over 4 plus ln 1 over 10, and this would be our final answer. Actually, we could probably simplify this further, so let me just remove that therefore, because we can write this as t is equal to the exponential of these first 4 terms, right? That's negative 20x squared plus 2x cubed plus 19 over 4 times the exponential of ln 1 over 10, right? Because here, remember, using laws of indices, if you've got, for example, e to the a plus b plus c, this can be written as e to the a plus b multiplied by e to the c. That's basically what we've done here. And the reason I've done that is because this exponential and that ln will cancel out, and this simplifies our expression to become, we've got the 1 over 10 multiplying our exponential here, negative 20x squared plus 2x cubed plus 19 over 4. And this is a simpler version, so we can say that's our final answer. Number 10, the equations of two straight lines are r is equal to I plus j plus 2ak plus lambda 3i plus 4j plus ak, and r is equal to negative 3i minus j plus 4k plus mu minus I plus 2j plus 2k, where a is a constant. Part A. Given that the acute angle between the directions of these two lines is a quarter pi, find the possible values of a. So we have been told that the angle between the directions of the two lines, let's call that theta, is a quarter pi, right? We know that the formula for angle between two lines is cos theta is equal to the dot product of the two vectors and then the product of their moduli. Okay, so let's start by finding the dot product of our two directions here. So our two directions, so that's, I'm going to write it in column vector notation because I think that's a bit easier to see. So 3, 4a dot, that's negative 1, 2, 2, and this gives us negative 3 plus 4 times 2, which is 8, plus 2a. Alright, so this simplifies to 5 plus 2a. That's our dot product, or scalar product if you prefer. And then we also need to find their respective moduli. So we'll start with the modulus of our first direction, so the modulus of 3, 4a, and we're saying this is equal to the square root of 3 squared plus 4 squared plus a, which will be 9 plus 16, which is 25, so root 25 plus a, root 25 plus a, this should be squared, plus a squared. Alright, and then we'll do the same for the other direction. The modulus of negative 1, 2, 2, that is equal to the square root of negative 1 squared plus 2 squared plus 2 squared. So that's 4 plus 4, which is 8, plus 1, that's 9, root 9 is 3. So we can write that cos theta is equal to their dot product, which is 5 plus 2a, 5 plus 2a over the product of their moduli, so that's 3 multiplied by root 25 plus a squared. Alright, and at the beginning we say that our theta is a quarter pi, so we can substitute that in and say that cos a quarter pi is equal to 5 plus 2a over 3 root 25 plus a squared. So let's evaluate cos of a quarter pi. Make sure you're in radians. That gives us root 2 over 2. So we're saying root 2 over 2 is equal to 5 plus 2a over 3 root 25 plus a squared. Okay, I'm just going to square both sides because I want to get rid of all these square roots that we have. They are not fun to work with. Okay, so be careful with how you square. So root 2 squared, so square the numerator then square the denominator. So root 2 squared will give us a 2 divided by 2 squared, which is 4, so that's half. We can write that as 1 over 2. So this is 1 over 2 is equal to, we'll do the same here, square the numerator, that's 5 plus 2a squared, over here in the denominator square the 3 first, so that's 9, then square the root 25 plus a squared, so that will just cancel out the square root sign, so 25 plus a squared. Alright, so let's do this on the side. We've got 1 over 2 is equal to 5 plus 2a squared over 9 times 25 plus a squared. I'm just going to expand the bracket in the denominator first before we cross multiply. What is 9 times 25? That is 225. So we've got 225 plus 9a squared. Now we're going to cross multiply so that we end up with 225 plus 9a squared is equal to 2 times 5 plus 2a squared. And now let's expand. This should be 225 plus 9a squared. Let's expand our right hand side. So that would be 4a squared plus, that's 20a plus 5 squared, which is 25. Alright, so that's 225 plus 9a squared is equal to 2 times 4a squared, that's 8a squared, 2 times 20a, that is 40a, 2 times 25, that is 50. Let's put everything on one side, so we've got 9a squared minus 8a squared minus 40a, be careful with your signs here, minus 50 plus 225, and this is equal to 0. So 9a squared minus 8a squared gives us a squared. Then we've got minus 40a. Then we've got minus 50 plus 225, which gives us a positive 175. And this is equal to 0. Pretty sure we should be able to factor this by side. We need factors of 175 that add up to negative 40. So that's negative 5 and negative 35. So that means a is equal to 5 and a is equal to 35. I believe that's what they want, possible values of a. Find the possible values of a. So we can conclude that therefore a is 5 or a is 35, and that is our final answer. Let's move on to part B. Given instead that the lines intersect, find the value of a and the position vector of the point of intersection. Alright, so we need the equations of the line, and again I will use column vector notation. Feel free to use IJK notation if you prefer, but I think this is a bit clearer and easier to see what's going on. So we've got 1, 1, 2a plus, that's lambda. And another thing to note, they said given instead that that means that the conditions from part A, or the solutions from part A is 5 and A is 35, do not apply because the situation or the scenario has changed. So don't assume that A is 5 or A is 35. Alright, so this is lambda times 3, 4, A. 3, 4, A. That's our first equation. Then our second one, I should probably write this as R1 and R2 so that we don't get any confusion. We've got the point -3, -1, 4. -3, -1, 4 plus mu, and our direction vector is -1 to 2. -1 to 2. And we're told that these two lines intersect. So if you want to find a point of intersection, you have to solve the equations that you have simultaneously. So that's what we're going to do here. From this first equation that we're calling R1, we can get 1 plus 3 lambda. 1 plus 3 lambda, that's from the x coordinate, and that must be equal to the x for R2, which would be -3 mu. -3 mu. And we'll do the same for the y coordinate. That's 1 plus 4 lambda. 1 plus 4 lambda is equal to -1 plus 2 mu. -1 plus 2 mu. And we'll do the same for the z coordinate. That's 2a plus a lambda. 2a plus a lambda is equal to, and then R2 we get 4 plus 2 mu. 4 plus 2 mu. Alright, so I'm going to use our first equation to make mu the subject of the formula. So we've got 1 plus 3 lambda is equal to -3 mu. So mu must be equal to -3 -1 -3 lambda. So mu is equal to -4 -3 lambda. And we can substitute this into the second equation, which is 1 plus 4 lambda is equal to -1 plus 2 mu, and we said our mu is -4 -3 lambda. Alright, so that's 1 plus 4 lambda is equal to -1, that's 2 times -4, so -8, 2 times -3 lambda, that's -6 lambda. 1 plus 4 lambda is equal to -9 -6 lambda. And now we want to make lambda subject of the formula. So that's 4 lambda plus 6 lambda is equal to -9 -1. 10 lambda is equal to -10. So lambda is equal to -1. Now that we have lambda, we can go back to this equation and evaluate mu. And we're saying that mu must be equal to -4 -3 times lambda, which is -1. So mu is equal to -4 plus 3, so that's -1. So we're saying our lambda is -1 and our mu is also -1. And we can now use this information in the third equation. So because we know what lambda is and we know what mu is, it will allow us to evaluate a. So that becomes 2a plus a lambda, lambda is -1, is equal to 4 plus 2 mu. Mu is -1, so that's 2a minus a is equal to, that's 4 minus 2, so that's 2. And that gives us a must be equal to 2. So what exactly is it that they want? I forgot the question. They want the position vector of the point of intersection. Alright, so to get the position vector of the point of intersection, we know that the general coordinates of any point that lies on R2 is given by these three expressions. This here would be the equivalent of x, y, z. So the x coordinate is -3 mu, the y coordinate is -1 plus 2 mu, and the z is 4 plus 2 mu. So we know what mu is. We know that at the point of intersection, at intersection, we evaluated what mu is at the point of intersection, and we said our mu is -1, we did that below here. We said our mu is -1, so that means the coordinates of that point of intersection must be -3 minus mu, and we're saying mu is -1, -1 plus 2 mu, and we're saying mu is -1, and 4 plus 2 mu, 4 plus 2 times -1. Alright, so this gives us the points. That's -3 plus 1, which is a -2, -1 minus 2, -3, 4 minus 2, that's a 2. So those are the coordinates of our point of intersection. So we can conclude that therefore A is 2 and point of intersection is, we said -2, -3, 2, -2, -3, 2, and this would be our final answer. Number 11, use the substitution 2x is equal to tan theta to find the exact value of the integral from 0 to 1 over 2 for 12 over 1 plus 4x squared with respect to x. Give your answer in the form a plus b pi, where a and b are rational numbers. Alright, so we are given the integral from 0 to 1 over 2 for 12, let me write that below, 12 over 1 plus 4x squared with respect to x, and we are given the substitution 2x is equal to tan theta. So what this means is that we want to convert everything to theta because we already have it in terms of x. So let's make theta subject of the formula here. Theta is arctan of 2x. So let's evaluate our limits now so that we convert them to be in terms of theta. So we'll start with at x is 0, that's our lower limit there. Theta would be arctan of 2 times 0, so arctan of 0, so theta is 0. And then at x is 1 over 2, theta is equal to arctan of 2 times 1 over 2, so that's arctan of 1, which is a quarter pi. So our new limits are 0 and a quarter pi, right? And we've got our 12 over 1 plus 4x squared with respect to x. And then the next thing we want to do is to get rid of dx. So that means we have to find an expression for dx in terms of d theta. So for that we'll use our substitution again. 2x is equal to tan theta. So if we differentiate this implicitly, we get that 2 is equal to, if you differentiate tan theta, you get sec squared theta, and this will be d theta dx. Alright, and so we said we want dx, an expression for dx, so let's make dx subject of the formula. So dx is equal to half sec squared theta d theta. So we can replace our dx here with half sec squared d theta. So that's the integral from 0 to a quarter pi of 12 over 1 plus 4x squared, and this is now being multiplied by half sec squared theta d theta, and that 2 can cancel out 12, so we have 6. And so the next thing that we have to do is we have to get rid of our 4x squared, and to do that we can use our substitution again. So our substitution is 2x is equal to tan theta, and we want to make 4x squared the subject of the formula. So we can do that by squaring both sides, and what we end up with is 2 squared, which is 4, x squared, which is x squared, and that's equal to tan squared theta. Now we could just put tan squared theta into our bracket here, but we can simplify it even further using the identity 1 plus tan squared theta is identical to sec squared theta. So this must mean tan squared theta is identical to sec squared theta minus 1. The reason we want to convert it to be in terms of sec squared theta is because we know how to integrate sec squared theta, but we don't know how to integrate tan squared theta. So that means we can say that our 4x squared is equal to sec squared theta minus 1. Sec squared theta minus 1. So we can go ahead and substitute and say we're integrating from 0 to 1/4 pi, and we've got 6 over 1 plus our 4x squared, which is being replaced by sec squared theta minus 1, sec squared theta minus 1, and this is squared, and this is times sec squared theta with respect to theta. So let's simplify what we have. We're integrating from 0 to 1/4 pi. We've got 6 over, the 1's will cancel out here, so that becomes sec squared theta, and this is squared, and it's being multiplied by sec squared theta d theta. So that sec squared theta cancels out the power 2, so it just ends up being 0 to 1/4 pi for 6 over sec squared theta d theta. And we know that we can write this as the integral from 0 to 1/4 pi of, I'll put the 6 outside the bracket because it's a constant, and we know that 1 over sec squared theta is the same as cos squared theta. So we're not integrating sec squared theta after all. But anyways, the point is we can use the identity, the double angle formula for cos 2 theta. Cos 2 theta is identical to 2 cos squared theta minus 1. We don't know how to integrate cos squared theta, or at least it's too complicated to carry out, so we want to simplify and get an expression for cos squared theta in terms of cos 2 theta. So that means we can use this identity and make cos squared theta the subject of the formula. So that's 2 cos squared theta is equal to 1 plus cos 2 theta. So cos squared theta is equal to 1 over 2 plus 1 over 2 cos 2 theta. Alright, so what we have over here is 6. In fact, I'll bring the 6 back inside because I think it will simplify our fractions when we multiply through. So we're saying cos squared theta is half plus half cos 2 theta d theta. And so we can multiply through by our 6, and we get that we've got 6 times half, which is 3, 6 times half cos 2 theta, so that's 3 cos 2 theta. And this is all with respect to theta. And now that we have simplified, we can finally integrate. If you integrate 3, you get 3 theta, plus if you integrate your cos 2 theta, you're going to get 1 over 2 sine 2 theta. Alright, and it's being multiplied by 3, of course, so that's why it's 3 over 2. And our limits are from 0 to 1/4 pi. We can go ahead and substitute our limits in. We'll start with the upper limit. That's 3 times 1/4 pi plus 3 over 2 sine 2 times 1/4 pi. Right? Be careful with your brackets here. Minus the lower limit. The lower limit will be 0 because 3 times 0 is 0, and then sine 0 is also 0. Okay. So what we end up with is 3 times 1/4 pi, which is 3/4 pi, plus 3 over 2 multiplied by sine of 1 over 2 pi, which gives us a 1. So that's multiplied by 1. So it means that our final answer here would be 3 over 2 plus 3 over 4 pi. And if you go back to the beginning, they wanted their answer in the form a plus b pi, where a and b are rational. As you can tell here, 3 over 2 is rational, 3 over 4 is rational. So that there is our final answer, and I believe that's the paper as well. So if you found this video useful, please leave a like and subscribe for more videos like this. Bye bye.